Mr. Chairman, ladies and gentlemen, I'm honored to have this opportunity to attend this conference. My name is Liyang Liu from Zhejiang University. The topic of my paper is Bidding Strategies for Generation Companies and Large Consumers in Carbon Emission Market Considering Electricity Spot Market Clearing Outcomes. The outline of my presentation as follows. The first part, I want to introduce the background of this research. The second part suggests the overall framework for carbon electricity market. The third and fourth part covers the model of carbon market clearing and bidding model we proposed for buyers and sellers in the carbon market. And then we introduce the numerical example and results. Finally, a simple conclusion of our work is given. Well, let's move on the first part of this topic. The motivation of this work like this. With the proposal of the goals of carbon peaking and carbon neutrality, China is accelerating the construction of a carbon emission trading market. The carbon market and electricity spot market achieve mutual coupling through the bidding strategies of market participants. Based on the electricity spot market clearing outcomes, research on the bidding strategies in the carbon market can not only provide reference for the participants, but also have great significance for the design of the carbon electricity market mechanism. The second part constructs the overall framework of this research. Because of carbon electricity market coupling, we should consider electricity spot market clearing outcomes when determining bidding strategies in the carbon market. Different from the electricity spot market, which is a discrete market, the carbon market is a continuous market. The mismatch between the clearing periods of two markets creates significant difficulties for the participants to develop timely and effective bidding strategies. So the discretization method is adopted in the carbon market to solve this problem. The compliance period of the carbon market is divided into multiple trading intervals with the same granularity as the clearing periods of electricity spot market. The focus on this paper is on how to determine the bidding strategies for carbon market participants under the condition that the electricity spot market clearing outcomes has been established. Let's move to the theoretical model of our research. The carbon market clearing process is represented using a centralized clearing method, and the clearing model for the carbon market in trading interval T is shown below. The objective function represents the maximization of social welfare, and these three constraints are the upper and lower bounds of the bid quantities of sellers and buyers, and the supply-demand balance respectively. The constructed model realizes the discretization of the CEA trading period. In this part, we propose the bidding models for buyers and sellers. As to bid quantity, The calculation method is shown below. The meaning of this formula is the bit quantity at this trading interval equals to planned usage minus actual usage in this interval and plus net accumulated quantity in previous interval. It should be noted that the bit quantity and net accumulated quantity can be positive or negative values. As to bid price, due to the different market factors considered by the buyers and sellers, it is necessary to discuss the pricing strategies for buyers and sellers separately. Discuss bid prices of buyers firstly. A buyer will choose the minimum value between the optimal bid price, the marginal carbon abatement cost, and the penalty for non-compliance as its bid price in carbon market. And when determining its optimal bid price, the buyers will consider three factors, namely compliance pressure, excess demand, and minimum carbon price after this trading interval. The offer prices of sellers are shown below. Different to buyers, sellers do not need to consider the marginal carbon abatement cost and the penalty for non-compliance. So the offer price of a seller equals to the optimal offer price, which are affected by sales pressure, excess supply, and maximum carbon price after this trading interval. In the case study part, we set 8 generation companies and 4 large consumers participating in both the electricity spot market and the carbon market. The simulation parameters are shown in table, and we assume that a compliance period consists of 50 trading intervals. The power demand of the consumers is generated from the actual industry load curves. In the simulation of a single compliance period, we set 3 cases with different total insurance of CEA. Case 1 increases the total insurance by 10%. Case 2 keeps it unchanged. Case 3 decreases it by 10%. The carbon price curves under 3 different cases are presented. Generally, the trends of carbon price are similar, featured by an initial decrease, followed by a relatively stable period, and a continuous rise, with significant fluctuations towards the end of the compliance period. Comparing the data from 3 cases, it is evident that a reduction in the total insurance increases the carbon price. The profit of 8 generation companies is shown on the right. We can observe that as the total insurance decreases, the profit of generation companies continues to decrease because of an increase on the carbon emission cost. However, for the gas-fired generation companies with lower carbon emission intensity, their profits are less affected. So we can infer that when CEA are scarce, cleaner generation companies will accumulate more CEA, which will help them gain a larger share of the carbon electricity market. Then we set a simulation of 4 compliance periods. The results are shown in the figure, including carbon price and the transaction volume. Through the simulation analysis of multiple compliance periods, the effectiveness of the proposed model can be verified. Taking the first compliance period as an example, the carbon price shows a trend of initial decreasing and then rising. That is because at the beginning of the compliance period, the CEA are sufficient, so the transaction volume is small. Near the end of the compliance period, under the pressure of compliance, buyers raised their bid prices, causing the carbon price to rise sharply and the transaction volume to surge. In this paper, the overall framework of generation companies and large consumers participating in the carbon electricity market is introduced firstly, and the discretization method of carbon market clearing is adopted. Then the centralized carbon market clearing model and bidding models of carbon market participants are introduced, respectively. Finally, through a numerical example, we provide analysis from the perspectives of single and multiple compliance periods. That's all for my presentation. If you have any question, please feel free to contact me. That's all. Thank you.